Hello and welcome to a ramble with me. So previously in a dramatic episode of my life, I recorded two videos, videos for two questions, and after an hour of recording, I discovered that I had not disconnected my headphones. They were connected to my tablet via Bluetooth, and so my poor tablet was trying to use the microphone on those headphones, which were in another room. So why I had not switched off the Bluetooth connection is a genuine puzzle. Maybe not so much a puzzle as a cautionary tale of do not procrastinate. I did think about switching off my headphones, but I did not, and now this was the aftermath anyway. So as a result of this unfortunate waste of my time, I have then gone through these questions once now, so I have done all of the untangling of my confusion, and all of the shock value has been removed. If I'm still shocked by something, then that will be a bit of a travesty, but also not completely impossible. So looking forward to that. If there is a detail that I might have missed the first time I was recording that I'm going to pick up this time around, that would be cool. But shouldn't be the case. Anyway, and the downside is that I do enjoy coming at these questions just with fresh eyes, just kind of recording the grappling in real time, whereas now I'm just coming to present the results of the grappling more than anything. But I do still hope that it will be a valuable video. The next two videos will still be valuable nonetheless. And without much further ado, and probably a bit less excitement in my voice than usual, let's get into it. So we are busy with November 2023, the department's paper 1, and today we're looking at question 8. So the question we are given f of x is equal to negative x cubed plus 6x squared minus 9x plus 4 is equal to x minus 1 squared times minus x plus 4, which is cool that they give it to us that way, because it's factorized for us, so we don't have to, we're not going to struggle too much with finding x-intercepts and things like that. Right. So the first question asks us to determine the coordinates of the turning points of f. So, first of all, important to identify what kind of function and therefore graph we're dealing with. This is a cubic function where the coefficient of x cubed is negative, so we know that it's going to be a cubic graph that looks like that. Probably, right? Always leave room for weird point of inflection-y looking stuff that might look like that, and we might not have turning points at all. Anyway, but first guess is that it looks like this. And so to find the turning points, we're looking for the places where the gradient of the curve is 0, right? The tangent to the curve at those points would be 0. We're looking at which x values will make that happen, and we know that the gradient function is given by f prime. So let's find what f prime is. In this case, it is negative 3x squared plus 12x minus 9, and we are looking for the place where f prime is equal to 0. So which x value makes this true? So we are solving this equation, which of course we could just plonk into the quadratic formula as it is, but I always like to try and factorize it because I don't know why. So I'm going to divide through by negative 3, just so I end up with just an x squared over here. And then this is straightforward enough to factorize, right? So x is then either equal to 3 or x is equal to 1. So you kind of see visually that this point here will be where x is equal to 1, and this turning point here will be where x is equal to 3. But of course we can verify that as well using some algebra. Okay, we want the full coordinates, not just the x values, so we're going to need to put these values back into the function. So let's start with x equal to 1, and I will put it into this form of the function, just fewer places to sub in the x. So that'll be 1 minus 1 squared, and then this minus x plus 4 bracket can also be written as 4 minus x, so I'm just going to write as 4 minus 1. So that will be 1 minus 1 is 0 squared, which is just 0, times 3, which is 0. Okay, and then the value of the function when x is equal to 3, so that will be 3 minus 1 squared times 4 minus 3, so that will be 2 squared, which is 4, times 1, which is 4. So our turning points are therefore, they occur at 1, 0, which is also an x-intercept, and also at 3, 4. So those are our two turning points. Okay, right, on to the next question. Next question says, draw a sketch graph of f, clearly label all the intercepts with the axes and any turning points. So we have our turning points. So we can just bring those down here. Okay, then the next easiest thing to get is the y-intercept, which we get by figuring out what the value of the function is when x is 0. So that will be negative 0 cubed plus 6 times 0 squared minus 9 times 0 plus 4, which is just equal to 4. So our y-intercept is 0, 4. Okay, then the x-intercept will also be easy to find because they've given us our function in factorized form already. So we are trying to figure out where is the function equal to 0. So we are solving this equation, right? And we can see that, well, either then x must be 1 in order to make this factor 0, or x must be 4 in order to make this factor 0, right? So our x-intercepts are going to be 1 and 0, which we already knew, and 4 and 0, right? And that's all we need. We need turning points, we need intercepts with axes, right? So we can plot our points. So this will be 0, 4. This will be 1, 0. And let's say this is 4, 0. And then this will be 3, 4. Right, and we can, just by virtue of knowing the shape of the cubic, we can then see that it'll be a cubic like that, right? But we could also, just to be sure, we could verify what kinds of turning points we have here. And in fact, it is a good habit just to check that none of your turning points are points of inflection. Yeah, but again, like I said, because we know the shape of the graph and that shape happens to fit the data, the points that we've got, you know, there isn't really a need to do all of that. But anyway, let's do it. So we can find f prime. Well, first off, we need, sorry, we're trying to find f double prime. We first need f prime. Alright, so f double prime is equal to negative 6x plus 12. So we can look at what's happening when x is equal to 1. Then we get negative 6 times 1 plus 12, which is negative 6 plus 12, which is positive 6. So that means at that point our graph is concave up, which confirms that this guy is a local minimum, right, which is what we have on our diagram, right? And then we can look at what's happening when x is equal to 3. So that will be 6 times 3, negative 6 times 3, sorry, plus 12. So that is negative 18 plus 12, which is negative 6. And that is a negative number, obviously. So that means our graph is concave down at this point. So positive, negative. Confirming that this point is a local maximum, which is indeed what we have on our diagram as well. We have a local max there. Right, things got crowded very quickly, so let's see if there's any hope of me cleaning this up a bit. Oh, I left a piece of my 3 behind. Oh. Okay, I think we'll just let that rest, honestly. You know what? It's not that deep. So, so that's a way that we can confirm that, yeah, our turning points look the way that they should. Right, then the next question says, use the graph to determine the values of k for which negative x cubed plus 6x squared minus 9x plus 4, which is the same as the definition of our function, is equal to k, will have 3 real and unequal roots, right? So roots just being solutions, right? So pretty much which outputs of this function are outputted by 3 different x values or 3 different inputs. So we can see that, for example, when k is equal to 4, x is either equal to 0 or x is equal to 3. Those are the only 2 values that you can put into this function that will produce a 4. Or likewise, when k is equal to 0, right, the only 2 input values that can produce that value, that can produce k equal to 0, is either 1 or 4, right? Only if you put these 2 values into this function will you get 0 as your output. So this question is asking us which outputs have 3 different possible input values. And so to do that, we can just look at, we can just draw a horizontal line and see where are the places that it's cutting the graph 3 times, because that tells us, for instance, whatever this y value is, it is produced by this input, and by this input. Whereas if we choose a y value down here, there's only one x value that creates that output. So the k's that work, or the y values that work, are y values in this range, right? The moment we go to k is equal to 0, there's only two solutions to the equation. The moment we go below that, there's only one solution. And likewise, the moment we get to k equal to 4, we only have 2 solutions. And once we go above that, we only get one solution, which is on this side of the x-axis. So, right, we are looking for values of k that are between 0 and 4. And we are not including 0 and 4 because, like I said, when k is equal to 0, we only have 2 solutions. And when k is equal to 4, we also only have 2 solutions. Right, and I've already checked the answers, so we are not doing that again in this video. Right. Next question says, the line gx is equal to ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. Okay, so the point of inflection will be here somewhere, and we are g is the tangent to the curve at that point. So potentially somewhere here. Did I draw the line? I don't know. No, I did. Okay, right. So we are looking for... what a bad tangent. No ways. Let's do that again. I know my drawings are not meant to be perfect, but hey, we definitely have to try. This is such a bad tangent, but anyway, better than before. Maybe it's just a bad curve to begin with. Right, so we're looking for the equation of the red line. In order to do that, we're going to first determine its gradient by saying, well, what is the gradient of the curve at this point? Because that will give us the gradient of the tangent. And to find that, we're going to use our first derivative and figure out, well, what is the gradient at this point? Okay, so now, first of all, we need the coordinates for this point so that we know which x value to find the gradient at. So we can use our second derivative, which we found somewhere before. Yeah, I don't know if I'm going to win here, but a girl can. You're definitely not winning. You know what? It's easy enough to just derive it again. So let's not pull teeth. So second derivative is negative 6x plus 12. To find the point of inflection, we are going to figure out where this second derivative is equal to 0. So we are solving this equation, which is negative 6x is equal to negative 12, and so x is equal to 2. So we now know that the x-coordinate is 2. It will help us to find the y-coordinate as well, because once we find the gradient of this line, we will now know the m in y is equal to mx plus c, or more precisely the a in y is equal to ax plus b. In order to then find the b, we'll need to sub in this point to figure out b. So let's summary get the y-coordinate, and we find that by putting that x is equal to 2 into the original function. So that is 2 minus 1 squared and 4 minus 2. So that's 1 squared, which is 1, and 4 minus 2 is 2. So the y-coordinate is also 2. Right, so now we can find the gradient of the curve when x is equal to 2. And we have our f prime. It is negative 3 times x squared plus 12 times 2 minus 9, which is negative 3 times 4 plus 24 minus 9, and that is minus 12 plus 12 is 12, minus 9 is 3. So we now know that our line is g of x is equal to 3x plus b. We have the gradient now. So to find b, we're going to use the fact that we know that when the input to the function is 2, the output is 2. So a times x, we found a to be 3. 3 times x plus b is equal to 2. So that is 6 plus b is equal to 2. And so therefore b must be negative 4. So the equation of g is 3x, or y is equal to 3x minus 4. Right, so that is the equation of our tangent. And then the last question says, calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. I mean, I don't know which other quadrant it would be in. But yes, as we know, in when we do geometry on the Cartesian plane, we measure our angles from the x-axis counterclockwise, right? So this is our theta, the angle between the x-axis and what's this? And the line G, right? So this is an angle of inclination question. once again, evidence that, you know, you shouldn't be isolating your studying for paper 1 and your studying for paper 2. Like, all of this knowledge can come in handy in either paper. So we're going to use our m is equal to tan theta formula. So in this case, we know that m is 3, and that is equal to tan theta. And so therefore, theta will be inverse of tan of 3, and I think that was 71,57. Yeah. Right, and that was that on that. Overall, not a horrible question, but subtle, bringing in, you know, just a requirement for you to know the meanings of certain things, points of inflection, in subtle ways, figuring out how to, a slightly different way to find, oh, is it that different? Yeah, it's not really that different of a way to find the tangent to the curve at a certain point. But yes, yeah, that ends my commentary. Let's leave it at that and catch you in the next video, where again I shall explain. Okay, I will not explain my Bluetooth saga again, but yeah, I'll be doing another question that I have already unfortunately done. But yeah, cool, bye.